We have studied something called the canonical forms, where we had two forms, sum of minterms and product of maxterms. Now we are going to study another form called the standard forms, which is appear with the canonical forms, but they express a little bit differently. Again, in standard forms, we have two forms, sum of a product and the product of sums. Those words are very confusing. Definitions are very confusing. So you need to clearly understand those correct names and the definition of them. Again, we have two canonical forms, sum of minterms and product of maxterms. And we have two standard forms, sum of a product and the product of maxterms. Sum of a product is defined as an OR of end terms. That is a sum of a product, standard form. And the product of sums, standard form, is defined as an AND of OR terms. So for example, this is a sum of product forms because we have each term as AND term, and all those terms are combined with the OR. So this is a sum of a product form. And another one is a standard product of sums form because each term is in sum form, and those are combined with the product, which is AND the terms. The difference between canonical form and standard form is that in standard form we don't require that every variable should be present. That's the only relaxation from canonical forms. To be a canonical forms, we should have a minterm or maxterms, both of which requires each variable present. But standard form, we don't require. Only we should have either OR of end terms or AND of OR terms. Then it's a standard form. So here is an example of another function, but it's neither sum of a product or product of a sums, because here we have AND terms combined with OR. So here this term in parentheses neither in AND term, pure AND term or OR term. So this is a mixed one. Again, this is a violation of pure AND terms or pure OR terms, so this cannot be a sum of a product or product of sums form. Standard sum of products, as we know, sum of minterms form is formed directly from the truth table. So where the function becomes 1, those corresponding rows are written in minterms. But we know that we can apply Boolean algebra properties and we can simplify that. So sum of a product is a result of the simplification actually from sum of a minterms form. Standard sum of a product, here we show how do we get from canonical sum of a minterms. Canonical sum of a minterms, for example, this is a given function, then we know that each index corresponds to certain term. So this is a full-blown sum of a minterms expression for function f. And then we apply Boolean property algebra step by step. Then we can find the most simplified form this way. Then this is a sum of a product form. It's not sum of minterms form, but it's a sum of a product form. So the original expression and the simplified expressions are identical in terms of functionality, but the huge difference is that the number of literals appearing in the expression. So as a more simplified function we get, which will eventually need less hardware. So that's some purpose of deriving standard forms. We'll get back to that in detail in later chapter. Here is a direct comparison. If we have a function f in sum of minterms, this is the hardware required. So we have 5 AND gates and 1 OR gate. But if we use a sum of a product form after the simplification, this is a result. So you can easily see that there is a hardware complexity difference. So we have a canonical form, sum of minterms of product of maxterms. And we have a standard form called the sum of a product or product of sums. The only difference is the hardware complexity. Then naturally we will have a few questions. How do we attain simpler expression, or how do we attain the simplest expression? How do we know that is a simplest? And what is that cost of the circuit? Is this the only one, simplest expression, or there's some other cost criteria? So we will talk about those one in detail in the following few lectures.